Okay, in this video we're going to help you make a simple base for a robot with a drive that's a chain drive. What's nice about this base is you do not have to cut any of the parts that are in the first global robot, and you have a frame in which you could put an arm, and we'll talk about different types of arms in another video. There's also modifications you'll have to make, so for example, we didn't have enough parts from available, like a control hub or the Omni wheels. But the basics of the robot follow the cross bars and channels that are seen here and in the back that are designed in the at the FTC chain drive example on the Rev Robotics site. So we'll get started on this. Okay, so the first thing we're going to think about in building our H-frame is maybe putting these cross beams, and you can see we have corner brackets on both sides. Now, corner brackets, you might say, first thing is as these side ones slide on, are going to make it a lot stronger because it won't twist in this direction. Alright, so we're going to talk a little bit about our motors right now. Your kit has two different types of motors. This is the 1 to 20 HD hex motor, and this is the core hex motor. And there's also some mounting brackets that come with them, which are different ones for different ones. But let's take a look at these motors from a mounting point of view. So if you see that there's a pattern, I've actually put the screws in there just for this video to show you the pattern of the hex motor. And then there's a pattern right around the shaft, which is those 6 holes there. That pattern is actually a different pattern, and the ones where the screws are, 4 of them can actually fit into these metal brackets. And I'll show you how to do that in a minute. Core hex has the 6 pattern there, and that 6 pattern fits very nicely with the pattern that is on this gearbox mounting bracket. So if we actually look at it from the top view, what you see is those holes line up very nicely. So you can use this for mounting the core hex motor. So we're going to actually assemble the core hex, sorry, not the core hex, the HD motor. I'm going to take these screws out and I'm going to show you how the mounting works for these. So the first thing is you'll see that you have 2 mounts, one that is angled and one that is flat. Now the way it works is you want to set the screws so that the hex heads of the 2 are aligned, creating a V, and we're going to be able to put a channel through there. When you do that, you'll see that all the patterns here for the motor will be aligned. So the first thing we're going to do, I find it easier to first put the motor on. So I'm going to put the motor on, and what I'm going to do is I'm going to put the motor in the top. If you notice, there's a pattern here that the motor can sit in different locations, and we're going to put it in this top left side. If you notice, there's an arrow, this arrow right here. When you sit in that top right side and the arrow goes to the bottom left side, the holes are aligned with the hole patterns. So we're going to take our screws and we're going to put the 4 screws in, and you want to use the 8mm screw. Once you get the first one in, don't tighten them until a little bit later. We're going to tighten them after we get them onto the rev. So we've got it loose. We got the 4 screws. 1, 2, 3, and I'm going to put the 4th screw on. Now we're going to put this, mount this onto a 420 channel, and it's really important that when you mount stuff, you know where since they slide, you know where they kind of go in. So we're going to actually put it in here. If you can sort of see, they kind of, the screws fit in, and they fit into the channel as they go.
One thing to mention is that on these motor mounts, you should put your screws where the slots are, not where the holes are, as the spacing of the screws is not where the holes are.
So we're going to actually put ours in 30 millimeters from the edge. So, and actually I'm going to put it on this edge because I want the wheel closer to the edge. So we're going to go, first thing I'm going to do is notice there's only 2 screws on the one side. And that's because you can't access the screws that are underneath the motor. So there's only 2 screws there. So I'm going to take this and I'm going to first go to 30 millimeters. I'm going to tighten, and it's nice because what I just do is I take this measuring tape and I go loose, make it a little bit loose, put it in. That's 30 millimeters. I tighten this here. I tighten the other side. Once I got that, what I'm going to do is I'm going to tighten the front facing mount. And then I will tighten the motor mount, the screws going into the motor. So fold it there. 1, 2, 3, 4. Now the advantage of this is by having the 2 metal brackets is a really strong mount and is not going to bend, particularly as the robot takes the weight of everything on this motor mount. When you're done, you can see each 420 channel will have 2 different wheels. And what you can see is we will then later put these wheels on here. So on to the next shot. Okay, so now you should have your 2 440 rails with the 2 motors attached. Motors going on the outside. And if you see, we'll have your smaller rev beams in the middle. And one of the things we're going to do is I'm actually going to take off one of the brackets, the corner brackets, but alright, so we have the battery holder here. I put 4 screws in. I took off 2 of the corner brackets from this back one, and so I'm going to slide this on here, but I am not going to tighten anything yet because I want the robot to slide on. I need the pieces to slide on. I'm going to actually put the bottom chain here. On the, whoops, this always happens. 2 pieces will come off, that'll go there, this will go here, and you can see they're on. Now for the, so now I'm going to keep these all loose, and you can sort of see this is going to be a little loose. And what I want to do is I want to take my one side and I'm going to slide it onto the 420. Rev beam. And by keeping everything loose, it'll allow me to slide things on. So I'm now going to loosen, actually I'll take this off for now. I'm going to loosen this. I'm going to put loosen this guy. We'll put this side on first. Great. Now, okay, so this is now at 100 millimeters. I'm going to tighten that side. I want to make this square. I'm going to tighten the second one. And I've gotten these things tightened as well. Okay, now I didn't tighten this one because I'm going to let that float. So I'm going to slide this up to here. And now I'm going to get, now notice this one slides around a little, but if I tighten this battery holder, it will make a square. So I'm going to actually do that for now. I'm just going to actually tighten one corner, and now I'm going to put this expansion hub on there. And the reason the expansion hub is having a difficult time is the screw is really long and my nut is quite a bit out. So I'm gonna keep screwed until it goes in. All the screws in. I'm gonna tighten it up a little bit, but I'm only gonna tighten this one side because this one side now is locked in and I can make it square. So I'm just gonna do one screw here. Okay, now I'm going to do the same thing for the second rev side. Now the problem is all the screws are on the underside, so I now have to turn it upside down. This one 100 millimeters. This one's right. This is a little bit forward. If you just eyeball it, it's not going to be very precise, so we're going to try to be precise with a ruler. And this looks like 100 millimeters. So with that, I'm going to tighten this back screw. So I'm going to tighten this screw to make sure that we've gotten it. And you want to make sure it's square, so I'm going to tighten this screw here. Here. On this side. And screw on this side. Now I need to make sure that all my screws get tight and everything is square. Right, finally, I haven't screwed this top bar in yet, right? But if you look at it, it's pretty strong. So what I'm going to do first is, I could put this whole thing in. I could unlock the hex up. I'm going to leave space between the battery and this so that I can actually route the motor wires underneath. But for now, I now need to tighten up the second thing. So I'm going to pull back and I'm going to tighten one at a time. One corner bracket at a time. And then the same thing on the other side. This side I can actually now let gravity help me here. And we'll tighten the screws on this side. And the last two screws on this side. Okay, so now we've got what's called an H frame. Why is it an H frame? Well, it's an H frame because it looks like an H. So we're tightening the battery in. Notice it's a lot easier to work on this when there's no wheels on the system because you can actually put it flat. And it's nice and flat. And you can, so I'm actually leave a little space between the battery and the rev, and this little space here so that we can pull some motors through between the two. So let's straighten the rev system. Alright, next thing we're going to do is we're going to wire the motors. Alright, you can stop. Okay, so the motors come with two wires, one which is black and red, and one which has multiple colors. The black and red is power, and this multicolored one with 4 is for the encoders on the motors. Unless you're planning on using the encoders, that wire will create more problems, but we're going to show you how to wire it all up. So for now, what we're going to do is, it's easy to see over here, it's good to know what is the front of the robot and what is the back of the robot. This is the back of the robot, and what we're going to do is we're going to plug, so this makes this the right side, and we're going to take the right side and we're going to plug it into ports 0 and 1. So this one will go here, and if you look at this, this will go, and it's keyed, meaning it can only go in one way. We will plug it in to this side. Alright, so I'm going to zip tie these to keep them neat. You may not want to do this at this point, although I find that carrying these two wires together all the time is kind of a nice thing, so I'm going to put a zip tie there, and then maybe every couple inches. Now, since these wires always go together, it may not be too bad to zip tie them in the beginning, but if you're limited in zip ties and can't get access to new ones, you may want to wait till after your robot's built or a little bit further along. So again, I like to actually make it really neat, so that way you can find out. The other thing I like to do is take a little piece of tape and label it. I don't have any tape here right now, but I do encourage that you put tape and labeling. So once this is zip tied, you can take, again, I like to keep it neat, keep them flat, one against the other, and what you'll see is it will make your process a lot easier of wiring. So you can cut off the excess with scissors. Be careful not to cut the wires. So we're going to cut this off. And so this will go into port 0 because this is the right back motor will be in port 0. So I'm going to actually sneak it up through the middle. Again, you don't want a lot of wire underneath, so I'm actually going to put the wire up here. This is going to go into port 0. And right next to port 0 is the 4 ports that go in for the
other way.
For the encoders. And they just go in sometimes it's hard, so you might need needle nose pliers, but you got to push it in all the way. Okay? So that is the first one. I'll come back with a bunch of other ones. Okay, so now I've got all the wheels off, but I've got this front motor. The next step I'm going to do is remove the front motor, and we're going to put a bracket on the front, and you'll see how I do that. Okay, so what we're going to do is we're going to put this bracket on. It's going to go underneath, and that will allow us, once we've tightened it up, we've got a place where we can actually put our axle and a collar, and the wheel go in the front. So for now, I'm just going to finish that off. So what we need to do is we need to build something that will go on the outer side. And so before we do that, we're going to put a lap bracket in the back, just like the FTC bot. Okay, so now I've got the lap brackets on the main extrusion here, and on the two side panels. Now, this lap bracket here, normally what happens is the single piece gets attached to the rev first, and then the other two are kind of a little loose. It's a little hard to get all three screws in, so what you see here is we first put in the screw that's on this, but we don't have the nuts on the other two. So what I'll first do is I will go put the cross beam across all this and connect it all up and have my next frame. Okay, so here's my lap bar, the cross beam that goes across, just like they have it in the FTC example, sorry, the Rev example for the FTC Rev kit. What we're missing here are the brackets on the front so that I can actually do the chain on the other side. So before I tighten these screws up, what I'm going to do is I'm going to make my brackets on the other side. All right? Okay, so for the front axle, I've put a 15-tooth sprocket, this small bushing, and it will go through the middle hole. And then on the other side, we will actually have the collar. And then I'll put it on the front rev, and so I'll show that next. But I've also put a 15-tooth sprocket on the motor. Okay, so now we have the chain on both sides. What I'm going to do is, now that I know where these brackets are going to go from here, I'm going to actually see that this is going to be as close as it is here. I'm going to have this bracket over here also get close, and I'm going to lock this screw in and this screw in and take off the side ones for now. And so we'll see the next step. What I'm going to do is we're going to add the wheels. We're going to flip the robot upside down and tighten up this cross bracket right here. Okay, so we've attached the crossbar at that single point. I'm now going to turn it over, and we are going to start attaching the wheels on both sides. So on this side, what we have is it's really simple. You will just put the wheel directly onto the axle. Now, over here, we don't have any more Omni wheels in our kit, so I've done a makeshift Omni wheel, which will be sort of a Tetrix one, but that'll be okay. And then what we're going to do is we are going to have another bracket on this side. Oops. And we will slide these lap brackets here, and I will slide this on onto this side, and then we will attach the wheel. I'll get that in a minute. Okay, so we've tightened up those lap brackets, but we made sure that the distances are the same on both ends. But what you see here is I've got the wheel. I've put a spacer, which is just a long bushing, and then a bushing through the other bracket. And now what you see is it's very nice that as I rotate this wheel, that one spins. We don't have a lot of bracing here, so don't worry for now. We'll put that bracing in a little bit later, but for now I think this is a okay design for what we're trying to do. You may want to move the wheel a little bit inward, but I think for now that's okay. Okay, now I've got both sides chained up with the Omni wheels in the front. The advantage of this now is I've got a nice H-frame. Now the downside is I have nothing across here, but my design was designed to not have to cut any rev. So what could I do to make it stronger? I can put another lap bar across the top, but I'm not going to do that because what I'm going to do next is start thinking about how might I put an arm. Remember the claw that we built? That might be a nice addition to this robot.